Okay, remember just now we talked about volume of revolution about x-axis. Now we're going to talk about volume of revolution about the y-axis. Now just quick recap. Just now when we talked about volume of revolution about x-axis, we're talking about the area bounded by the curve and the x-axis, and then you rotate it, right? And then you get something like that. This is A, this is B, and this is a volume of revolution about x-axis, because the curve is bounded by the curve and the x-axis, and you take this area, rotate, and we learned that this is AB pi y square dx. Why pi y square? Because you talk about each slice. Each slice here, each this here, the radius is this is delta x, just already consider the limits, and the radius is y. So each this is pi y squared dx, and we sum it up. Now, similarly, if you want to have a curve like that, and then this is C, P, let's use P and Q for consistency. And you want this area, you want to rotate it like that. Similarly to this, now, which is actually this, right? Yes, we want to get a shape like that. Now, let's go back. So, if you consider volume of a disk, which means this disk, is it obvious that the volume of this disk, which is like that, drawing not very good, yes, is the radius is x, the thickness is delta y. So using the volume of a cylinder, typical cylinder, pi x squared dy, delta y. So I'm not going to elaborate further, alright, because ultimately we are going to have summation volume. Actually, if I want to insert one more step, actually the volume of solid generated is actually the sum, maybe before that, maybe this sum of this, correct, when I equals to 1 to n, correct, if you consider the thickness of delta y tending to 0, okay, this is actually the volume. But how? Of course, we all know that we will use this. How you get from here to here, we will not worry about it. But actually, this is equivalent. This and this in calculus are equivalent. So let's contrast this. If it's x-axis, we get pi y squared dx. If it's y-axis, it is, leave me from P to Q, pi x squared dy. Now, you notice it's almost quite similar. It's quite similar, analogous to the area formula, except that now this is with a pi over x squared. That's pi. If it's x-axis, it's pi y squared dx. Okay, let's use an example to illustrate this.